Hangout on Air is live, and this Hangout on Air is live. All right, so volume 3 of my preparation for a talk regarding property-based testing, and yeah, so I put together a rough outline. Some of it I'm not sure if I should remove or not, but I believe that in a way it probably does belong, just because it provides context. Specifically, my outline talking about what is object-oriented programming, what's functional programming, what's the difference between the two, and then discussing very briefly what ecosystems exist for each one of them. In this case, in the talk that I'm giving, I'm saying that within the context of .NET, specifically C# for OOP and F# for FP. OOP is object-oriented programming. FP is functional programming. The ecosystems are pretty much the same, with the exception of a little bit more libraries. Anything that you do in C# you can do in F#. However, things that you do in F# require great care, if even possible, to do in C#. So, in regards to ecosystem, what I wanted to focus on is how they both share the unit test frameworks, such as NUnit, XUnit, MSTest. However, in addition to those particular test automation frameworks, or should I say unit test frameworks, with functional programming within the context of .NET, specifically F#, which is a functional first programming language, it also has, I would like to say, a framework called FSCheck. FSCheck is a derivative of QuickCheck from the Haskell ecosystem, and it essentially, well, it challenges your assumptions. It is a tool that enhances the way that we reason about our code. But before we get to that, because we're talking about test automation frameworks, I then asked the audience, hey audience, someone explain to me what a unit test is. And, you know, a member of the audience will probably say, it's a unit test is a test that tests a unit of code, something to that effect. And I'll say, okay. So what's an example of a unit test? Like, if we wanted to unit test 2 + 3 = 5, how will we write that? And they may say, well, your inputs are 2 and 3. Your output is 5. So your test is 2 + 3, and you want to assert that 5 is the result of that addition method. Okay. Or operation or function. I say, okay. But I probably don't want to lead with that. I'll probably want to say, because I'm kind of automatically telling them to give me an example. But what I want to say is, you know, if someone can explain to me how you would write a unit test to perform addition, how would you do that? Okay, that sounds better. If I frame it that way, if someone, let me start over. How could we write a unit test for addition? And I'll just leave it just like that. And then they'll say, you know, some arbitrary numbers, 2 and 3 and 5, operands being 2 and 3, and the sum will be 5. We assert that 2 + 3 = 5. Okay, and then that's where I hook them in, and I say, Well, gee willikers. It sounded like you just gave me an example-based test. Hence, you're giving me a specific case or a specific example for each input and a specific example of the output. Or translated, you're giving me an example in which you specify specific inputs and a specific output to be tested together, like as one unit. Like in order to write a unit test, or in order to unit test addition, then we must have 2, we must have 3, and we must have 5 within our unit test that we're going to use. 2 and 3 are going to be the operands, and 5 is going to be what we're going to assert when we pass those operands into an operation. That is an example-based test. Well, okay. So how would we... Let's talk about multiplication. How would we write a unit test for multiplication? And something very similar. They say, 2 and 3, or any arbitrary numbers. And, well, 2 times 3 is 6. So they would specify that the test would be 2 and 3. That's used as the operands. They pass it into a function called, or operation called multiply. And we want to assert that the result of that multiply operation is 6. Right? I say, okay. So that kind of follows the same flow as the unit test for addition. The audience nods their head. All right, cool. So here's my question. How do you write a unit test for an edge case? And I'll just let the audience scratch their chin, and more likely they'll probably say, well, you have to think about, an edge case or something that's not common. And then I take them to a definition of what an edge case is via Wikipedia. And then I ask the audience, when writing a unit test, is there a way to auto-generate an edge case instead of you having to think of it yourself? And the audience may raise an eyebrow. And they'll say, maybe people that review property-based testing, they'll say, yeah, property-based testing. Like, Is there any other way? Before I talk about property-based testing, they won't be able to come up with an answer. And so then I say, all right, well, there is a way to auto-generate edge cases where you rely on computing to flesh out edge cases for you instead of you having to brainstorm them yourself. And the way that we do this is through property-based testing. The context that I'm using is F# as a programming language. F# is a functional first programming language. And property-based testing is a tool that is embraced within the functional programming community. Whether it's Haskell, whether it's F#, whether it's, I'm sure Scala has support for it. It's property-based testing. And in property-based testing, it's a tool that challenges your assumptions about a function. In addition, I would say that it's a tool used to enhance the way that we reason about our code. When we perform property-based testing, it is a tool within our arsenal that enhances the way that we reason about our code. Okay. You guys interested about this? They say, yeah. All right, let's do some demos, right? And so from there, I share my screen. Come here. Present to everybody. And from there, I will, launch Visual Studio. And there is a property-based testing solution. And I will pretty much just get rid of that. And I'll get rid of this over here. And I just have this, okay? Let me bring this over a little bit more. And so I say, hey, let's write a test in which we want to flesh out edge cases for a unit test that we will write for multiplication. And so the value for multiplying two numbers is greater than the value from adding two numbers. Okay. And so, something that I should probably do is I should probably write the code, the actual unit test for doing addition and for doing multiplication. And then I said, well, what if we want to flesh out some edge cases? And once I write that code, then I start talking about a demo for property-based testing. All right, so that's something I need to put in my notes. In fact, this right here, I probably want to say demo addition and multiplication, something like that. Okay. I'll print that onto my server. And so that's printing. I could ball up this hard copy that I have right here. Okay. And I go back to my test. And so in my test, I basically say, when doing property-based testing, we must define a generator or generators, depending on the data that we are going to generate for our tests. Okay. So I could say let generator equals A or B for arbitrary dot generate. And within angle brackets, I could say int as the data type that I want to generate values for. Okay. Then I can say within F#, I can use some funky syntax saying I'm going to leverage generator here and the generator there so that I can generate two values that don't necessarily have to be the same. And in order for me to do that, I would say arbitrary dot from generator. And from there, I could say, I believe right here, I could say prop dot for all, and then use the backwards pipe operator. and then pass in a function that will say, something's not right. I am forgetting something. I need to actually call it map. No. I need to call it map. I need to call it map. No. I think this is right. From gen. And then I think I do gen.map 2. And then I think I have actually, I think I'm supposed to do it like, shoot. I need to take these two generated values and create a tuple out of it. So I think I do something like gen.map2, and it's going to take an x and a y value per generator, and we want that to basically be a tuple x, y. And then we want to basically pipe that into our arbitrary.fromGenerator function. And then from there we say property.forAll, and we can say this function that takes A and B as a tuple. We want to say that A times B is greater than A plus B. And that builds. And because that builds, I can do a Control RT for run tests as a shortcut. And I could test my assumption that A times B, regardless of the number for A, or regardless of the value for A, and regardless of the value for B, when I multiply the two of them together, they will always be greater than A plus B. And we see that the test failed because it's used an example of 2 and -1. 2 being A, -1 being B, meaning that 2 times -1 is 2. Is it greater than 2 plus -1, which is 1? Well, -2 is not greater than -1. -1 is greater than -2, and that's why it failed. So, introducing filters, because we can then say, oh, well, I didn't really know about that case. So you could say, we could say this arb.generate int, and then we could say gen.filter, and then that's going to take a function, and we say x goes to x not equal, and I would say x is greater than 0. So as long as these values are greater than 0, then the product of A and B will always be greater than the sum of A and B. And so that's what I have here. And if I try that out, then I'll do Control RT. And we have a new failure, and our failure is saying 2 and 2. Well, 2 times 2 is 4, and 2 plus 2 is 4, meaning that our assumption that multiplying two numbers will always be greater than adding two numbers, well, that's false. And here's the edge case for that, 2 and 2. So if we wanted to, we could then say, well, we could add another filter and say that x cannot be 2, which that doesn't really look right because we should allow 2's into our data generation. It's just when we generate two 2's, right, or a pair of 2's, that's the exception that we want to filter out. Not quite sure what's the best way of doing that here. I'm curious if I could do that over here. So if I get rid of that here and I go to this right here, then theoretically I should have a xy like that. And I say x not equal to and y not equal to. And the compiler appears to be happy with that. So if I do Control RT, we filter out the pair of 2's and say, with the exception of a pair of 2's, the product of two numbers will always be greater than the sum of two numbers. And well, that's false again, because we have an exception to that assumption, which is 1 and 4. Well, 1 times 4 is 4, and 1 plus 4 is 5. Well, so 4 is not greater than 5. And so here we may want to add a filter where we say x is greater than 0. Actually, instead of anding that, we could say, we just add another filter and say x is not equal to 1. Okay. So we can try that out and do Control RT and see if there's any other specific cases, right? Because now we have three filters. We have a value must be greater than 0, a value cannot be 1, and a value and a pair of values that we're going to use as operands cannot be 2. And this finally passes, right? So by default, we ran 100 tests. The question is, it might be a good idea to increase the number of values that we generate by, say, that's 1,000. We could say 10,000. And we can say 100,000. In F sharp, we can use an underscore to represent a comma. And we can run this again, Control RT. And it's going to take a little bit for it to execute because we just went from 100 to 100,000. So whatever order of magnitude that is, yeah, that's what we're doing. And sooner or later that should wrap up. I don't think we're doing too much. Maybe I should have kept it at 10,000. I shouldn't have to cancel it though. It would be great if there was like some type of progress bar that can show up as a detail for like to reflect what number we're on. And it finally passed. So we generated 100,000 different data inputs, and everything still passes. Now, something I don't like is, oh, do we really have to say x is greater than 0? We shouldn't have to do that. There's probably a better way of doing that. Let's take this 100,000 to just 100, okay? Now, remember when we did this earlier, we got a failure because we had negative numbers in here. And so this should probably fail again. And instead of saying x is greater than 0, see, we have 3 and -2. Maybe we should visit our assertion part of this prop.forAll and say that the absolute value of a times b will always be greater than, maybe I should be fair and say the absolute value of a plus b. So I could do that, see what happens. And they say -2 and -1. So what does that mean? Well, -2 times -1 is going to be 2, and -2 plus -1 is going to be -3, if I'm right? Right? -2 and -1 is -3. -2 times -1 is -2 times -1 is, I thought it was 2. See, that's me not knowing my math. So if I put in my calculator, it's sad that I can't do math. -2 times -1, yeah, it's 2. And -2 plus -1, -2 plus -1, it's -3, right? So 2 is greater than -3. I'm not sure why we're getting that. Oh, because we say the absolute value, right? So the absolute value of -2 and -1 is 2. That's the absolute value. And -2 plus -1 will be, that it would be -3, but we're doing the absolute value, which is 3, which means that this is greater. So that's another exception that this provides, So there's different ways that you can manipulate this test, but the whole point is for a property-based test to basically raise flags on what you assume and it will provide you specific inputs that falsify your assumption about a function, right? And when I say function, well, this is I would like to say a lambda or anonymous function. And so we could easily give this function a name, right? So we can say, where do I want to put this at? We could say, let give, or is product greater than sum. And we can, I mean, honestly, you could literally just take this right here and you can throw it right here. And we could do something like this. Of course, that's kind of wordy. I don't like it. So we could also do, should be able to do back. Oh, where's this at? Why is this in the middle? Should be able to do his products greater than sum. Like that. And that builds and compiles, we should get a very similar error. So something that we could do is we could remove the absolute value of multiplication, or the product that stems from it is greater than just sum, without qualifying it with the absolute function over it. And then we can do something like this. When we run that, it should pass. No, it doesn't. And why? Because it's using 0. It found yet another exception of 0, and 0 times anything is 0, right? So what that means is we have 7 and 0 as the operands. So it's saying that, where are we at? It's saying that 7 times 0 is greater than 7 plus 0, which is 7, and that's false. 0 is not greater than 7. So we can update our filter to say, oh yeah, by the way, our value cannot be 0 either. And then we can run that. And that's green. And something I want to do is I want to make sure my arrows align. All right, I feel better now. And so that's with max test 100. If we do max test 1000 and run it, that's green. If we do max test 10,000 and run it, that's green as well. Okay. So we just ran 10,000 generated inputs into our function of is product greater than sum to basically, maybe prove is not the best term, but to have a warm, fuzzy feeling that our assumption is correct. However, our assumption is most likely correct only based on certain exceptions, which is that a generated value cannot be 1 and a generated value also cannot be 0. With those exceptions, our assumption about a product of two numbers being greater, or the absolute value of a product of two numbers being greater than the sum of two numbers, is going to be true as long as, in addition to that, the pair of numbers are not 2. Okay. which is this right here. And that's pretty much it. So, all right. So that was volume 3 of my practice talk. The demo was pretty choppy, so I need to focus on that being more congruent, more fluid. Practice, practice, practice. It's not until the 26th, so I'll probably do another 3 or 4 times, and things should fall into place better. All right, that's it. So, adios. I'm out. Scott Nimrod, trying to be the top-notch developer in the state of Florida. Available for hire. I do mobile development. I do native, or should I say, desktop development, and I focus on .NET technologies to deliver solutions to conquer technical challenges for businesses. That's it. Adios. Peace.